For most of this year, I've been lucky enough to spend a lot of time learning about how to implement agents. And lately, what I've been looking into is how to implement self-learning agents. I've been experimenting with that. And that's the point of this image that's here. I built an app that's very much like this image, where the app is based on that's on a 2D board, and multiple agents play the game. They play each other in the game, which is really fun, very, very interesting. These agents use different models and things like that, but so I want to explain what what I did, to implement these agents. It's been a journey. To sum up, what I've learned through this so far is that with agents, you need to know how to ask. And that's what I want to explore in this video. So first I want to show you the actual game itself, this board game. So let me go to that. So here's the UI to the board. What you can do is there's what are called agent players, and I'll explain what an agent player is as we go through the video. Let me just get the game started. So what I can do is I can select an existing agent player, and this one it's GPT-5 Nano. So an agent player. Its main characteristic is what model does it use. So I select that, and then I'll select another one, and I'll pick Gemini 2.5 Flash. So it's OpenAI versus Gemini here, and select that, and then start the game. So the game is started. And what it'll go in it's basically an autopilot right now. The agents are going to play each other until one of them wins the game or it's a draw. I've never seen a game go to a draw yet, but I do see the agents. One wins, one loses. So the GPT-5 Nano just went to the center square here, and now Gemini 2.5 Flash is thinking. You can see there's a timer on the on the right side of the screen. It says think time. It's just about 20 seconds now. So this is one interesting thing that I really ran into. I was not expecting this. How long all these different high-powered models spend trying to figure out how to move in this game. Now, the self-learning part of this is that these agent players start out, they don't know the rules of the game. They have to learn that through experience. So the agent itself has tools that are given to the agent player so that the agent player can build up what's called a playbook. A playbook is a document that agent players use to learn how to play the game. So these two agent players that are running right now have played some games. They've learned some of the rules of the game. They're not really good at it, but they know enough of the basics. So they're starting to play the game. So they're going to try, and the goal is to score, and whatever that means. And then the goal is, of course, to win. So that's what's happening here. So there's strategy involved. They're trying to get enough squares to score, and they're trying to use squares to block your opponent from scoring. So that's what's going on in this game. So while this is running, this is going to take a while to run. We're already 2 minutes into the game, and it's made 3 moves so far. Again, very surprising how long these things take. So let me show you some other features of the game real quick. There's a help. So we're in the game page. There's a description of what I mean by an agent player, and I'll describe that as we go through the video. There's a playbook viewer, which is just a UI for looking at different agent players' playbook to see how that playbook has evolved over time. So their version of playbook. So the app has this ability to do that. There's also something that I added later on, which I call an agent role viewer, and there's agent role tools. Basically, this is giving the agent players tools that it can actually modify its system prompt, which is a little unique, but it's experimenting. Would this help them learn to play the game better or not? And then just to look at the data that's being captured by the game, there's a leaderboard, and then there's a game action log viewer as well. So let me go into, I'll show you the leaderboard real quick, and then the log viewer. So the leaderboard is, let's see, we're Nano is playing. So this is the current game that's going on right now. It's in progress. I'll zoom in here. You can see the game is in progress, and it just shows either games that Nano has played so far, which ones it won, lost, had to cancel one game because I ran into a bug that I had to fix in the code, things like that. So that's what's going on here. And the nice thing is, if I go to some of these prior games, like this game was just played a little while ago, what you can do is walk through the game. I can go back to the first move and walk through each move in the game, and I can see where, like, there's a score where there are 3 blocks or 3 squares in a row, and Nano scored a point. And now Flash is trying to block Nano to prevent it from scoring some more. So it's kind of on the defense here. But then Nano does this kind of crazy move that ended up scoring, looks like 4 points, or actually, I don't know, more than that. Anyways, it scored a bunch of points. So there's some crazy moves in scoring rules in this game that these players have to learn. Now, the other thing is there's this game action log viewer, and this is where I kind of highlight every time an agent gets prompted, and then the things that it does during the course of handling that prompt and sending back a response. So these agent players are being told, you're playing a game, when you get prompted, you're supposed to move, and that's what this prompt is basically saying. So it does a cool tool call to retrieve the game state. That's a tool. There's a tool call to retrieve the player's playbook. So here's this player's playbook, Nano's playbook, that is built up over the course of playing the game. This document, this is data that's just being captured by the system. This app is built in Akka, and the backend Akka, there's a lot of Akka backend involved in this, handling a lot of data, because these games are generating quite a bit of data. In any case, these playbooks start empty. And this text here was written by the agent over time as it learned and learned, and it has multiple revisions of the playbook. It gets, it made a move, and then here's a response. So this is an interesting thing as well. This is the text that's generated by the model as a result of making a move in the game. So that's what's going on here. So these are some of the things that are in this game app. The playbook viewer, I'll go to Nano. You can see that has updated its playbook 9 times so far. And this updating that goes on, I've added a diff feature to this so I can see what changes were made from the prior version of the playbook to the next version of the playbook. So you can see in this last revision of its playbook, it actually made quite a few changes. Now, if you heard that sound, that was the sound of one of the players scoring. It made a move and it scored. So that the diff has been an interesting feature, but I can scroll backwards through time to the beginning where this is the initial playbook. It started empty, and this is the first thing that it wrote. And then over time, it's been making revisions to the playbook all the way up until the current playbook. So that's the critical learning tool in this app, is this playbook. Now, another tool though is like I said, the system prompt is changeable, and this is really interesting because initially, let me go back to the first version of the system prompt. This was the agent players are given us default system prompt that I handcrafted torturously over the last few months, trying to get better at asking. So there's quite a bit of information that was in the system prompt, and this agent player blew it away, Nano. And then I reset it because I thought, okay, maybe that was a bug. I did some tweaking of things in the game. Another score happened, but then it just wiped it out again. So this Nano, it's kind of showing that the playbook, in a way, is taking over for the system prompt in telling Nano how to play the game. It's not really, this is useless, basically, with just this information. So that's been really interesting as well. So that's what's going on in this game. So you can see here, I went back to the live game. The last score was a diagonal 3 squares done by Gemini 2.5 Flash. If I go back a move, this is where Nano scored a vertical 3 squares. So it's right now the game is tied at 1-1. So that's what's going on in the game. Just a quick overview. There's a lot more to cover here. So how do I ask? How do you ask? How do you build an agent that asks? So I kind of built a mental model of my own for thinking about what I think of as the anatomy of an agent. Somebody won the game. That was the sound of somebody winning the game. So here's a diagram. It's a crazy diagram. It's my diagram. I've gone through many revisions of this diagram. Hopefully it makes sense to you, but let me go through it. I mean, this is kind of the anatomy of an agent. The big thing is there's the model, of course. I mean, we just plug into one of the models that are out there. That's it. So the agent uses models to reason, to perform the really sophisticated task. The agent itself, I think one of the big learnings for me was that one of the most critical things that the agent does is it builds the context. And the context is basically the information that's given to the model when it asks the model to do something. Learning how to ask. This is what I had to learn how to ask. And so in that, there's a lot involved that the agents do to build this context that goes to the model so that the model does some useful work for you. So this is a kind of a fairly high level breakdown of the things that go into the context. But I've asked some of the models, I asked Claude, I asked Gemini, I asked GPT, what are the layers of the context that agents typically use, and each one gave me a different answer. They were pretty much on par with each other, but there were definitely some very distinct differences. In any case, let me just go through it. There's a system prompt that is URA type of thing. That's very traditional. You saw my system prompt, which Nano threw away and basically doesn't need anymore. And the other one is the user prompt. This is the whole thing with early on when we were talking about prompt engineering. This is basically saying it's your turn, make a move in this game, for example. But then there's short-term memory. And short-term memory is the context of the conversation so far in a session. So in this game, a session is an agent player playing the game. So there's actually 2 sessions going on here for the 2 agent players. Each one has their own unique session, their own private conversation that's going on with their own model. So the session, the short-term memory is composed of things like the user prompt and then tool descriptions, tool requests and tool responses. So this is where the agent goes into a reason action loop, or react loop they call it. I've heard it called, where you send your initial user prompt to the model. And part of that user prompt has a description of the tools that are available. The model looks at the request, looks at the other things in context, looks at the tool descriptions, goes, okay, I need to call a tool to get the game state. So it sends a request back to the agent saying, hey, call the game state tool. Here's the parameters I want you to use. The agent calls that tool, gets a response back, and then sends that all back to the model. That information goes into the short-term memory. So it builds up these conversations, between each prompt and response, and everything that happens in between that the model does. It's captured as part of the short-term memory. Long-term memory, as I think of, is that this is external data stored, in databases or retrieved from services or whatever, but it's external, that is useful to the context of what you want to give to the model when you're asking it to do something. So RAG is one of the most famous ones, so far, but that's just one it's a technique for retrieving data. It's very cool, very sophisticated, but it's just one technique. In this game, I'm not using RAG. I'm simply giving the model a tool to retrieve its long-term memory, which in this case is its playbook, and also its system prompt, because that's modifiable by the agent now because it's got tools. And then finally, there's the tools themselves, and that the tools need to have a description so that the model knows what tools are available and how, and has an idea of what they do and how to use them. And then there's the tool responses that come back from it. So there's kind of the request responses that are important. But all this information is loaded up into context and sent to the model. So the idea is that that came to my mind, maybe not, maybe take it with a grain of salt. This is my view on this, but this I'm trying to internalize, agents, build up my intuition on it, is that the model is kind of like, think of it as a robot. The robot has a brain and it has a body. The brain is the reasoning part. It's the thing that makes all the decisions about what to do, and the body supports that. It's providing input, it's performing actions for the brain, those types of things. So that's where, just for fun, I just took the diagram I had generated for the model, I'm sorry, for the agent as a robot, and overlaid my diagram on top of it, so that you have the brain up in the head, and then but the context is the thing, the go-between between the body and the brain. This is kind of like the spinal cord feeding information to the brain to have the brain know, basically asking it what to do, and then the response coming back is, things coming from the model back to the body, telling the body to do something. Now, the interesting thing, though, that's I think important to understand, that's different from our mental model of ourselves or any kind of thinking type of animal or whatever, is that our brains are stateful. We maintain a state. You listening to this video have been maintaining a state of what I've been saying in this video. You having a conversation with a person, you have the state of that conversation back and forth, continuously guiding you through the conversation and constantly being updated. With these models, that's not the case. And in fact, I remember I saw a video a long time ago, years ago, about a disorder in the brain that's called anterograde amnesia. And what this video actually showed was a person that had this, and this person at some point in his life, and he had a very interesting life, very talented person, but something happened, I forget what it was, but he got this brain disorder, and he can never learn anymore. So he doesn't, every time he sees, say, somebody he knows from his past before he had this problem, it's like he hasn't seen them for a long time. They walk out of the room and come back in, and he forgot that they just left and came back in, that type of thing. That's what we're dealing here with these models. That every time you send a context to the model, you're starting fresh as far as the model. The model, who are you? What do you want? Type of thing. So this is where the model is critical, and this is where it came down to, with agents, you need to know how to ask. So I've been spending a lot of time fine-tuning the ask of my agent to the model to improve the performance of the agent. And this has been a journey. Where as I've been fine-tuning the ask, I've been seeing a noticeable improvement in the performance of the game. If I go back to the game, okay, the game is over. It took 8 minutes and 22 seconds. Before, I was seeing games that lasted 15, 20, 30 minutes to occur. I was seeing moves, individual moves that were taking 2, 3, 5 minutes to complete. Now you see, and this is also kind of surprising, is that you see that some of the moves are pretty quick. Like the first move was 14 seconds, and it looks like some of the other moves that Nano made were about 1 minute and 14 seconds, 22 seconds. But you can also see um, Gemini 2.5 Flash, most of its moves, three of it did 4 moves, and they were all over 1 minute. So there's a lot of thinking time going on here. So it's not fast. There's a lot of think time happening here, which is really, I was very, very surprised by this. These models, all the models I've been testing, have been struggling with trying to make a move in this game. And I've been struggling with trying to make them do this faster. What am I missing? What do I need to do here? Fascinating. This has been really fascinating. So that's what's been going on. So the agent player concept in this game is that each agent player, when you create an agent player, you're basically plugging in a specific brain into the body. And so the 2 players that played, it was GPT-5 Nano was one agent player, and Gemini 2.5 Flash was another agent player. But I played with Claude, I played with the Google models, I played, GPT-5, for example, not Mini or Nano, but GPT-5 is horribly slow. I can't get that thing to move fast at all. Surprisingly, GPT-5 Nano is actually one of the best players right now. Really surprised me. In any case, I've been trying to fine tune things, and what's happening, that's the self-learning part of my agents is that it has that playbook and it has a modifiable system prompt that the model is allowed to read and modify using tools. That is the learning process so far that is in this game. So each agent player is unique and is shaped by its own in-game experiences. As it plays games, it's learning, it's modifying. The main thing, again, is it's modifying its playbook to understand how to play the game. Really, really interesting. So I just want to show you real quick some of the things that I had to do in this to in code to deal with this. So that the first thing is that the agent, this is the agent, the agent itself has the code. This is not an agent. The code itself is quite simple. This is where the actual these lines here, 44 through 50, are where the agent makes a call to the model. There's not a lot of other code. There's some tools that are provided, as I've been talking about the tools. There's some code here for handling exceptions because the models aren't always well behaved. They because my prompts aren't that good. In some cases, they've gotten more well behaved as I've been fine tuning the prompts. And the fine tuning is really in written language. So here's the user prompt when to make a move. I've been fine tuning this prompt. Here's the user prompt when the game is over. I've been fine tuning this prompt as well, trying to encourage the agents to do their post-game analysis and update their playbooks and maybe their system prompt based on their experience from that game. So the next time they play a game, they'll do better. Same thing with tools. The tools have, like, this is the tool for getting the game state. You can see there's a description. I've been refining this description. There's a move tool. You're making a move. I've been refining this description. There's a tool for getting the move history. You can see there's a fair amount of text here. Fine tuning this. Playbook tool. The playbook tool has 2 tools, one to read and one to write. A lot of fine tuning I've been doing here. Same thing with the system prompt, fine tuning. And then finally, this is the where the initial system prompt is fed into a brand new agent player. And you can see it's fairly long. Been fine tuning this a lot. It's been very, very helpful, at least in the early stages of when the agent players don't have a playbook or it's a very minimal playbook. But it seems like what I'm learning is that the importance of the playbook goes way up over time, and as obviously the importance of the system prompt has gone way down as agents have been learning. Kind of an interesting finding. So those are the things that have been going on. So it's been pretty interesting. The things to consider. This whole game was built. This whole app was built using Akka, and including the UI is it's all written in just basic HTML, JavaScript, and CSS. I'm not using any frameworks or anything like that. All written with great assistance from AI coding agents. But the whole thing is in Akka. I just real quick to go back to the IDE. You can see that there's quite a number of back-end classes here. There's event source entities. There's eventing, going on between things. There's views. There's quite a bunch of back-end code here because there's quite a bit of data that is getting generated by this game. But in reality, if you think about this, this is not unlike some type of real enterprise type of agent that does some really useful work for you in your applications. And those agents learn. They improve over time. How do you build that? It takes data to do that. So you have to have a good back end for it. So that's the Akka part that's really been powerful to join with the agent which is built with Akka as well. So that you can check out Akka. You can go to Akka.io to get the marketing side, and go to Akka.io to get the the documentation. So that kind of sums it up. The whole thing is that, like I said in the beginning, one of my big aha here was with agents, you need to know how to ask. And the harder the work, the more non-trivial I think that the agent is, the more non-trivial the thing that it does, it's more important. The importance of how it asks is really critical. And understanding the anatomy of agents to do that is I think is essential. It's once I got kind of powered through it, I feel like I'm finally getting on the other side of over like a year of just hearing about things, and because everything's been moving so fast, I feel like I'm starting to finally kind of get a little bit on the other side where I'm reasonably less clumsy in implementing an agent. So that's where things are at. So give it a try. The link to the repo for this project, you can download it and run it locally. I was running it locally on my system when we ran the game here right now. You can run the whole thing locally. It's pretty straightforward. Give it check it out. So hope this helps. Keep learning, like and subscribe, and hopefully we'll catch you in the next one.